So we can do the straddle pricing with our Excel again. Let's go back to our straddle example here. So, okay, here let's create a tree for the straddle. So I think this is the right place. So straddle and the strike price. Strike price is go to here 98.7282. So 7282. Okay, this strike price. So let's call this one is the straddle K. Okay, straddle K. So it is straddle. So this one matures at 1 year. So when this is this one, so let's calculate it. So this straddle is max. First, we have to consider call option. So max of this one minus straddle K and 0. It is call option part. Well, strike price is how higher than market price, so call option value is 0. But it means that there is a put option value. So straddle, so we add put option. So max, now straddle K minus this bond price and 0. So the price of this straddle at the maturity is this one when interest rate is 5%. So for each scenario of this one and this one, we have bond price, this one and this one, this one. So it means we have straddle price of this one and this one and this one. So, right? So if interest rate goes up a lot, go down a lot, you will have a higher payoff. When interest doesn't move in the middle, you have a lower payoff. Now, let's calculate the price of this straddle in 6 months. So we calculate expected value first because here 6 months later the risk neutral probability is this one. So first we calculate expected value. So RNPP multiplied by this one going up plus 1 minus RNPP multiplied by this one. So it is expected value, but now we have to discount it back. We have to discount it with here 6 months later in this scenario interest rate is this one. So we have to discount with this rate. So parentheses and exponential of minus this one and then 0.5 year. So it is the price of straddle in 6 months when interest rate is up. We copy and paste this one. Okay. Then it is the expectation of this one and this one, and then discount it with this rate, right? This rate. Now, straddle price today. Now again we calculate expected price, but now this is risk neutral probability with this one and this one. We have to use this one now, right? This is RMP. So let's calculate expected value RMP multiplied by this one up scenario and 1 minus RMP multiplied by down scenario, and then we can discount it exponential of minus this one multiplied by 0.5. So this is our straddle price. So we computed our straddle price. Okay. So today's the contract that pays this one in 1 year. The price of this contract is this one. Let's highlight. The price of this straddle is $0.68. Interesting, isn't it? Now, up to this point, we assume the initial interest rate tree was given. God gave us the interest rate tree. But in order to use this model in practice, we have to come up with the method to generate the interest rate tree. There is one way to generate interest rate tree. First, define the expected change in interest rate in the future. So you can ask like interest rate strategist and ask what is the expected change of interest rate for the next 6 months, something like this. Okay, so you can define expected change in interest rate. And then we introduce error in our predictions as follow. So R1U equal R0 plus M0. It is M0 is expected change from today to 6 months. And delta is 6 months, so it is 0.5. Plus sigma, delta 1 power of 1 half. And R1D, R0, M0 multiplied by delta minus sigma delta root delta for the first period when up and down movement occur with equal probability. For the second period, okay, now you can get another expectation, another change of interest rate from 6 months to 1 year, and then we call it as M1, okay, M1 over here. M1 over here, you put that number. So R2U is, it should start up movement because it goes up 2 times. So R1U multiplied by M1 sigma delta plus sigma root delta, and R2UD is R1U plus M1 delta minus sigma root delta, and R2DU is R1D plus M1 delta plus sigma root delta, and finally the down scenario, R2DT equals R1D plus M1 delta minus sigma root delta, and so on. If you have longer tree, more than 2 period tree, or like a 3 stage or 4 stage long tree, you can just keep iterating this one to build a large tree. This model naturally generates recombining tree. Remember, in our tree, up, down, and down, up should meet each other. And in this setting, this occurs. Note that by substituting R1U and R1D in the first equation, we find R2UD equals R0 plus M0 M1 delta, which is exactly same to R2DU. So this kind of a generating tree is recombining tree.